So this problem is going to be a stoichiometry problem. We didn't get a chance to do a limiting or a full-out stoichiometry problem with writing a balanced chemical equation, so I wanted to make sure that I did one so you guys would have something to reference. So I'm going to do number 75 from chapter 3, which you guys had part of your summer homework assignment. So the question states, solutions of sodium carbonate and silver nitrate react to form solid silver carbonate in a solution of sodium nitrate. Okay, so the very first thing that I'm going to want to do is write a chemical reaction. So it's saying that I have sodium carbonate. So sodium is Na+1, carbonate is CO3 -2. Since the charges don't cancel, they crisscross. So sodium carbonate is going to be Na2CO3. Okay. And then it also tells me that I have silver nitrate. Okay, so silver is +1, nitrate is NO3 -1. Charges cancel, therefore I will have NaGO3. And then lucky for this problem, it tells me what I actually make. It tells me that I make silver carbonate. So same thing here. So silver has a +1 charge, carbonate has a -2 charge, charges don't cancel, therefore I'll have Ag2CO3. And then it also tells me that I create sodium nitrate. Both of them have 1 charges, so it'll just be NaNO3. Okay? And then the last thing that I have to do is balance the chemical equation, especially since I'm doing going to be needing mole ratios. So there's 2 sodiums here, so I need to put a 2 here. There's 1 carbonate, 1 silver, 2 silver, so I need to put a 2 here, and then I should be good to go. Okay? So let me continue on with the problem. The problem states, a solution containing 3.50 grams of sodium carbonate is mixed with 1 containing 5 grams of silver nitrate. And then it basically wants to know how much do I have of each one of these things at the end of the reaction. Okay, so one of them will not be there at all because that will be the limiting reactant. Okay, and then I'll have to figure out how much of each product I make as well. And then one of these will be excess. Okay, so the very first thing that I'm going to have to do is figure out who is limiting and who is in excess. Okay. So since I have grams for each one of these, that'll be the first thing that I have to do. Now, if you remember when you're solving for limiting reactant, you pick a product and you convert to its moles. Make sure you stop at moles because molar masses can affect what's going to be limiting or not. Okay? So I'm going to start. So I'm just going to go to I'll go to sodium. Let's see. No, I'm just going to go to silver carbonate because it's the first guy that's present. So I'm going to say in question mark moles of silver carbonate is equal to, the first one that I have is 3.50 grams of sodium carbonate. Okay, so I'm going to say, if I was to calculate this molar mass, so for every 1 mole of sodium carbonate, if I was to calculate all of that, so it would be sodium is 22.99, so I'm going to have 22.99 times 2 plus 12.01 plus 16 times 3, and you should get 105.99 grams is its molar mass. Okay, and then my mole ratio is for every 1 mole of sodium carbonate, I have 1 mole of silver carbonate. So that's basically telling me that I'm going to be creating, and if I watch sig figs here, I need 0.330 moles of silver carbonate. Sorry, forgot the 2 there. Okay. Alright, so far so good. Okay, and then I have to do the same thing with my other reactant. So I have to say question mark, moles, and I have to convert to the same product, because if I convert to a different one, I'm changing my variable and I don't want to do that. So Ag2CO3 is equal to the 5 grams of silver nitrate. Okay, and if I was using my periodic table to figure out silver nitrate's molar mass, it would be somewhere along the lines of 169.88 grams of silver nitrate. And that's for 1 mole of silver nitrate. Right? Okay, so now this time my ratio is not going to be, it's not 1 to 1, it's going to be 2 to 1 this time. So for every 2 moles of silver nitrate. I'm going to need 1 mole of silver carbonate. And that makes sense, right? Because there's 2 moles here where there's only 1 and 1 mole. Okay. Now if I was to calculate that through, carrying 3 sig figs, I should get 0.0147 moles of silver carbonate. Sorry, let me rip this off so you can see it. Of silver carbonate. Okay? So based off of this information, based off of the 3.5 grams of sodium carbonate that I was given, it would give me 0.0330, which is more than what the silver nitrate gives me. Okay? So now if you remember, limiting means you can only make as much as the smallest number, right? So in this case, this grams is going to limit how much product I'm making. Okay? Remember that? Where I'm ultimately going to have some of this left over. Okay, so already I can say that off the bat, after this chemical reaction takes place, there will be none of the silver nitrate left over because it's going to stop the reaction. Okay, so now I just have to convert for everything else. Okay, so the first thing that I'm going to do is now I'm going to take this number. Okay, after you figure out who's limiting, that number is used for every other conversion. Okay, so now I'm going to use this number and convert back to the sodium carbonate to figure out how much I actually need from the 3.50. Okay, so I'm going to say question mark grams of sodium carbonate, and I'm going to set that equal to my 0.0147 moles of silver nitrate. Now if you're, or silver carbonate, I'm sorry. Now if you remember, you could either use this number or the 5, but since it's already in moles, I'm going to stay there just so I don't have to do an extra conversion. Okay? So I'm going to go back and I'm going to say, okay, again, my ratio is going to be 1:1. So for every 1 mole of silver carbonate, I will have 1 mole of sodium carbonate. Okay? And then for every 1 mole of sodium carbonate, it will weigh, which we already had before, 1.599 grams of sodium carbonate. Okay? And then I could do 0.0147 times 105.99. And if I plug that into my calculator, what's that going to give me is 1.56 grams, and that's needed. Okay. How much was I given? 3.50. So then I'm going to do 3.50 grams minus the 1.56 that I need, and I'm going to have 1.94 Na2CO3 left. So that means that this is in excess. Okay? So far, I know how much of each of my reactants I'm going to have. I'm going to have none of the silver nitrate, and I'll have 1.94 sodium carbonate left because that's in excess. And then the last 2 conversions that I have to do are of my products from my limiting. So the first one that I'm going to do is I'm going to say question mark grams of, I'm going to do silver carbonate first because I already have that in moles. And that's equal to the 0.147 moles of silver carbonate, right? And for every 1 mole, it's going to weigh, if I was to calculate that, 275.75 grams, which means I'm going to make 4.05 grams of Ag2CO3. And then the last part here that I'm going to have to do is to my other product. So I'm going to say, I'm going to actually flip to the other side. Question mark grams of NaNO3. and that's going to be equal to, now I'm gonna go back just to show you could do this if you wanted to, but you don't have to. I'm going to go back and use the 5 grams of silver nitrate just to show you that everything's going to work out the same if you do it differently, okay? Because ultimately, if you remember, conversions just mean 1, okay? So you're not actually changing the value, you're just changing the unit, okay? Which means I'm going to have 1 mole of silver nitrate, that 169.88 grams of silver nitrate, and then I'm going to do a 2 mole of sodium nitrate for every 1 mole of silver nitrate. Okay, so then moles cancels, and then my last conversion would be for every 1 mole of sodium nitrate, it would weigh 85 grams of sodium nitrate. Okay, so if I was to plug this all into my calculator, 1 divided by 169.88 times 2 times 85, I should get 5.00 grams of sodium nitrate produced. Okay, so after this chemical reaction takes place, I'm going to have 5 grams of sodium nitrate made, 4.05 grams of silver carbonate produced, 1.94 grams of sodium carbonate left over since it was a reactant, and 0 grams of silver nitrate will be left over as well. Okay, so I hope this helped you with remembering limiting reactants, and make sure you let me know if you have any questions.